Welcome to the Stormsurf video surf forecast for the week starting Sunday, October 30th. Looking at significant wave heights for the North Pacific Ocean, we see an area of almost 39-foot seas just shy of the Aleutian Islands. This from a gale, producing some swell, radiating towards mainly the U.S. West Coast. And also we see some residual activity here of gales also tracking off the U.S. West Coast. Let's get into the details. Let's start this week's tour by taking a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales do form, help direct their track. Right now we have a very healthy flow pushing off Japan with winds to, about 170 knots. Pushing over the date line, relatively flat, no real trough indicated until you get here to the Gulf of Alaska, but then there's no real winds in this area either. So most of the energy proceeding off Japan, pushing over the date line, making it to the western Gulf of Alaska, then finally dipping into a trough, that little hole, if you want to, or dip in the jet here. That creates counterclockwise flow aloft, sort of like consider it a river or something, an eddy in the upper atmosphere. Counterclockwise flow, and also down at the surface, that's the hallmark of low pressure. And of course, low pressure generates wind, wind generates seas, and seas, as they radiate away from the fetch area, create swell, and swell makes surf when it hits your beach. But again, in this trough, we are just starting to get the first little hints of winds here at 130 knots flowing into the trough. We need more than that. So we roll this out, and here we go, moving into about Tuesday. We see a trough, the real trough, starting to develop here, being fed by, 1, 2, 3, that is 160, 170 knot winds. That is quite healthy. Notice the jet is consolidated too. And as we get into Tuesday, decent little trough digs out here, moving into the eastern Gulf of Alaska. Now there you go, that sort of hook signature. That's really what you're looking for. That suggests good energy. And look at this, 170 plus knot winds pushing into that trough. And there you go, even better by Thursday night into Friday. And whoa, there we go, 190 knot winds here in this one frame. Late Thursday night, that is a great setup for gale, if not storm development. Then notice the trough starts moving east, starts pinching off a little bit, but then another trough moves into the area on Sunday. Now notice it's not being fed by nearly as strong winds, but still a trough nonetheless. Whoops, there we go. But also notice back here off Japan, the jet is starting to split, and there's this general sense that wind energy and energy in general is starting to slacken off in the jet. So the main focus looks like the Tuesday, Thursday, Friday time frame, all focused in the Gulf of Alaska. Now that is pretty much to be expected, because remember, with La Niña in play, most of the cold water is sitting right here, and one would expect high pressure to be building north of that. That'd be right here, which would push the jet to the north, causing a ridge here, and then falling south into a trough over the Gulf of Alaska. That's exactly what's been going on, and the expectation is that will be the pattern for the bulk of this coming winter. We'll see if it actually holds that way. Next up, we take a look at surface level pressure, surface level winds. Now remember, from the significant wave height chart, we saw decent seas, 39 foot in this area right here, and sure enough, we have a gale. Actually, yeah, a gale, not a storm. 45 knot winds. It has to be 50 knots or greater to be a storm. Anyway, we have just that tiny little fetch there, but then a broad area extending almost from the northern Kuril Islands over the date line and into the western Gulf of 35 knot winds. So that should help agitate the ocean surface pretty well. Also notice another gale off the a low pressure system off the U.S. West Coast, Northern California, little sliver of 30 knot winds, and another one trying to set up here in the Gulf of Alaska with 30 knot winds. So there is plenty of activity, but also notice all of it is pretty much traversing from flat west to east, and very little energy pushed down at Hawaii. Most all of it, the target is from Vancouver Island to Point Conception. We'll roll this out. Notice by Sunday night, all the activity here is moving north of the Aleutian, still 35 knot winds, south of the Aleutians, and 30-knot winds over broad area, but 30-knot winds will only get you maybe 11 or 12 second period swell, which will decay significantly en route to the U.S. West Coast. Anyway, we get into Monday. Now remember, the jet is building here. A trough is starting to dig out, and sure enough, we have 40-knot winds building on Monday to 55 knots. That's a storm on Monday night into Tuesday, working its way through the Gulf of Alaska here, falling southeast, 55-knot winds, still into midday Tuesday down to 50-knot. And notice this is aimed sort of from this area southward down in here somewhere, more or less, and then the flow sort of flattens out. Also notice behind it another gale up here with 45-knot winds. That starts even on, well, let's just go back just to see. It comes off the Kuril Islands on Monday and traverses the whole north portion of the North Pacific, but moving very fast right behind, and then fades out, only be picked up by a new gale developing with 40-knot winds and feeding this area into Thursday. This is all completely expected, totally supported by the jet stream. Remember the trough that's digging out right here, so good upper level support. Then things kind of start backing off some into Friday, but notice another gale is supposed to develop off the Kuril Islands. Kind of wonder whether this is maybe a little overhyped given the state of the jet stream on Saturday, but we'll go with it for now. 45-knot winds on the dateline to 50-knot storm status. Again, following very much a similar track. Broad area of 40 to 50-knot winds. Sunday moving into the Gulf of Alaska. And yet another system behind that on the dateline with 50-knot winds. Whoops, and that's at 180 hours. So the model's looking very impressive 180 hours out. Now let's take a look at the effect of those winds on the ocean surface. As we noted before, what is this? 37-foot seas here, just shy of the Aleutians, 18Z Sunday. This from the system that's expected to move into the Bering Sea. We'll just roll this out, and sure enough, it starts moving up. Seas start decaying, though we know there's a broad area of 30-knot winds here, and that's still generating 20 to 26-foot seas, 18-foot, even west of the dateline. Certainly, much swell should result from that. And then here comes the first in a series of storms, Monday night into Tuesday. What do we got here in terms of seas? 39-foot seas on midday Tuesday, but continuing up to 42 feet. 42.9 to be precise, but that's just one little grid square. That's a half a degree by a half a degree. That's 30 square miles, or I'm sorry, 30 miles by 30 nautical miles, 90 square, 900 square miles. In the central Gulf, with another system developing north of that, this follows exactly the wind models we saw. Now notice there's just a little sliver of high pressure here that's deflecting everything to the north, which opens up the swell window right here from, let's say, San Francisco southward to Point Conception and down into Southern California. The angle's a little bit steep. You really want most of the storms for Southern California to be somewhere south of the 40-degree line. Anyway, roll it out. Another system on Thursday, but again, racing off to the northeast. Then there's a bit of a break. I mean, still continued 18 to 20-foot seas out in this area, even on Saturday. Let's roll this back just a little bit. So there you go, 20-foot seas on Friday afternoon, directly pointed at Central and Northern California. Lots of swell likely for the latter part of the week and beyond for this area. And then here comes our next storm. Now, the interesting part here is we don't think the jet really is supportive of the winds and the seas that we're seeing here. This is a model of a model, remember that. Upper level winds support lower level storm formation. The surface level models are used to feed the wave model, which then determines what the impact of those winds are on the ocean surface. So basically, if the jet stream is overstated, our general thought is then the rest of this stuff gets overstated. Not a direct correlation, but a rough guideline. Anyway, so we're out to Saturday night. This system builds with what? 41-foot seas, max seas over this entire domain, 41.5 feet over a tiny little area there, and continuing over the dateline into the Gulf of Alaska, 180 hours out with yet another system behind that If all this comes together, it will be swell after swell after swell, all mainly pushing in this direction. So just for fun, we'll do this. We'll overlay the Great Circle paths, and here you can see Northern California. Here's like the 309, 308 degree path coming into California. Then we'll go through this real quick and do the same thing for Hawaii. But what we're looking at is just follow the storm track, and if the seas are pushing along these lines towards a target, then that's where the majority of the swell will be. You see, generally, we're using Northern California as a proxy for California in general, but you can see that last one there actually pushed directly. I mean, you get a perfect track right there up the 296 degree track to Northern California. Okay, now we'll do it again for Hawaii. So here we go. Here's the Great Circle paths into Hawaii, and you can see if storms are moving this way, really out into here is the main swell production area relative to Hawaii. But just watch this as we do this. You'll see these storms form here. They're pushing this way. That's the direction the swell's going. Sideband energy pushing south. And we'll just roll through this quick. You can actually see the sea heights trying to push down, but not making it very well. Now that one's a little bit better relative to Hawaii. This is the forecast one, 144 hours out. Sideband energy for Hawaii, and then another one. But really, most of the storm generation swell generation would occur out here. But that doesn't mean that Hawaii will be left out of the mix. So for the first part of the week, kind of a slack pattern. But then once you get into Wednesday here and into Friday, you can definitely see potential swell. A little bit of trades blowing, but definitely swell. These are actual surf heights, but you get the general idea. And then here you go for, let's say, Northern California. Once it gets going on about Thursday, the surf never gets below, let's say, 11 feet and periods higher. The issue might be wind at time, but not too bad. And even Southern California at exposed breaks, we'll say San Diego, gets some decent-sized surf, even with the islands, even with the north angle, all sorts of things. Still, potentially, some decent surf if one wants to believe the automated forecasts and, for that matter, the models in general. But overall, the trend looks very positive and very much looks like winter is starting in the North Pacific. Let's go take a look at long-term projections. And we'll talk specifically about the MJO, Madden-Julian Oscillation, and about La Niña. First off, we're going to look at winds in the Kelvin wave generation area. Again, this is the East Pacific here, West Pacific here. This is Papua New Guinea, the date line here. Actual wind speeds per the TAO buoy array. These are buoys strung across the equator, really used for monitoring El Nino and La Niña, but can also be used to monitor the status of the Madden-Julian Oscillation. The Madden-Julian Oscillation is a periodic oscillation that is typically 4 to 6 weeks in one phase over the Pacific, travels from west to east, sort of against the grain, let's say in the active phase, and then does 4 to 6 weeks in the inactive phase, moving across the Pacific. Right now, east winds, trades are in control over the entire Pacific, including the Kelvin wave generation area, which is from 135 east to about 170 west, 5 degrees north or south of the equator. This is the area where Kelvin waves can be generated during El Nino years, but it also gives us some indication of what's going on with the jet stream. Sometimes. Now, things are a bit disconnected right now. Here's actual anomalies, differences from normal in this time of year. The contours are water temperatures. I'm not looking at that. We're just looking at the arrows. And this suggests weak east anomalies in the Kelvin wave generation area. That would suggest the inactive phase of the MJO, and the inactive phase of the MJO generally tends to suppress winds in the jet stream, tends to make them weaker, tends to pull the jet stream apart, and clearly that is not the case right now. The jet is looking very healthy, even though we have easterly anomalies. So one would look just at this data and go, inactive phase of the MJO is in control, but yet looking at the jet stream, clearly that's not the case. Let's dig a little deeper. Here's another way to look at winds. This is the past performance of winds from September 30th, working towards, I can pull this down just a little bit here. Here's the current date right here. Blues are easterly anomalies. Oranges and yellows are westerly anomalies. The Kelvin wave generation area is from about here to here. This is the whole world on one planet, so outside of the Pacific Ocean. So you go down right here, and you can see generally Blues have been in control, easterly anomalies. And then you look at the forecast here. Here's beginning of the GFS operational forecast, and a strong easterly wind burst is suspected here in the next 3 or 4 days. That is completely different than what one would expect from looking at the jet stream charts. So there's some sort of disconnect going on here. We'll talk about that a little bit more in a minute. So looking at more signals of the MJO. The MJO is the major mode other than El Nino, La Niña, of getting us some sort of a sense of what's going to happen long-term surf-wise. So this model here, the statistical model, basically shows a dead neutral pattern. You look at it and goes, nothing going on, a little bit of a inactive phase of the MJO, sort of, but it's so tiny. It just says dead neutral. The GEFS model, Ensemble GFS model, suggests for the next 5 to 7 days, dead neutral, but then the active phase of the MJO building, where you're kind of going, okay. So these two models are, not in agreement at all whatsoever. The blues suggest more precipitation than normal in this area, which is typical of the active phase of the MJO. Oranges, reds suggest high pressure, less precipitation, less sunlight reflectivity off the ocean surface, and therefore the inactive phase of the MJO. Now, to totally contradict what we just saw there, we look at these phase diagram charts. These tell you where the active phase of the MJO is. Assume you're looking down on the North Pole, though that's not what this really is. The active phase of the MJO moves from west to east, from the Indian Ocean, over the maritime continent, consider this Bali, New Guinea, to the over the West Pacific, over the dateline in the West Pacific, East Pacific, over the U.S., into the Atlantic, over Africa, on the equator, and then back into the Indian Ocean. The big dot right here is where the active phase of the MJO is per the ECMF model. The forecast for the next 14 days, this is interesting. This only showed up about 3 days ago or so, now suggests the active phase building, and so this is the cone of death, if you want to call it that, or just when the active phase is in here, it's very weak and indiscernible. The further away from you get from there, the stronger it is. This suggests in the next, 7, 8, 9 days, something like that the active phase is going to start showing up on the dateline and getting reasonably strong, moving off to the east. And now the GEFS model suggests basically the same thing, some slight variation on it, maybe developing a little bit further to the west off the maritime continent and doing the same thing. So this is most interesting, again suggesting the active phase of the MJO might wake up. And then there's the trusty CFS model. Again, this is 850 millibar wind anomalies up about 4,500 feet, but a good proxy for what's going on down at the surface. Here's current time. Past time is here. The Kelvin wave generation area, 135 to about 170, so from about here to here, that's really where we're interested. And this suggests easterly anomalies building strong in the next week. We'll actually overlay this now. Now, what this is saying is, again, hard to discern. Yeah, is that an active phase of the MJO? Not really. Back here in July, even that wasn't a real active phase of the MJO. There were westerly anomalies associated with that, and another supposedly back in August. But the MJO is extremely weak. There are these pockets of easterly anomalies. The forecast says the inactive phase is supposed to show up maybe in sometime in mid-November or so, again in the Kelvin wave generation area right in here. But the pattern is very weak, but clearly something is going on just by looking at the jet stream, looking at the storm track, and the models are suggesting that the active phase, now you see it here in this model, very weak, but the two models we just saw before, here and here, suggests a stronger pattern than what this model suggests over the next 2 weeks. So that would put you into about here. One would say a stronger MJO signal active than what this projects. So this model, which we've normally been hanging our hat on, we're kind of scratching our heads, go maybe not, or it's just slow to catch up. Hard to say. So we'll leave the MJO signal discussion for right now as undecided, but we have other data that we will present in a little bit. We're just going to keep you hanging for a second. Anyway, so looking at the ocean subsurface wise, we're talking, now we're going to go talk La Nina, El Nino, that sort of thing for a moment. Just put the MJO out of your mind for a minute. Anyway, subsurface temperatures. This is the ocean, West Pacific here, East Pacific here. We're just talking 2 degrees north or south of the equator in the Pacific, okay? And what we see is actual water temperatures, warm water in the west, a very shallow pool of warm water at the surface in the east, pretty typical of La Nina. If it was El Nino, you see much more warm water over here. These isotherm lines, deeper, a larger pool of warm water there, but that's all but gone now. We look subsurface-wise, no matter what's going on subsurface-wise, clearly this is a weak La Nina signal. There is no warm water at depth here. There's no Kelvin waves moving from west to east. That is pockets of warm water. So if you had west winds, remember we were looking at the, talking about the Kelvin wave generation area, you get west anomalies driven by the active phase of the MJO in this area of the Pacific. It takes warm water here, pushes it down to depth, and you start getting these, instead of like a cool pocket here, you get a warm pocket that works its way across, gurgles up to the surface, and starts creating a warm pool here. We see none of that. Instead, we see neutral or slightly below normal temperatures, and at depth, we see a clear 4 degree below normal pocket here at 140 west. That's more or less south of Hawaii. Another model also suggests the same thing, but also suggests cooler than normal water off of Ecuador here in the far East Pacific, a typical La Nina sort of pattern. And the heat anomaly pattern across the Pacific Ocean, West Pacific here, East Pacific here, this is back a year ago. Kelvin wave number 5, Kelvin wave number 6, driven by westerly anomalies blowing in the Kelvin wave generation area, moving into the East Pacific. But then here is the cool water that made its advance in the March-April time frame. And just looking down here, you can see kind of a big burst, and now things just sort of hanging, maybe a little bit more activity in La Nina, but nothing super pronounced at the moment. So a weak La Nina signal suggested. Next, we take a look at surface water anomalies. You can clearly see lots of warm water here off of Mexico, Central America, off South America, the whole way across the Pacific, much warmer than normal. But it's this area right here. If you have a strong La Nina, you'd expect to see a lot of cooling developing here off of Peru, radiating up off of Ecuador, and so we see warm water here, just a tiny little cool pocket. Another pocket building here off the Galapagos. Trades are blowing pretty good here, not much above normal, but enough to get some upwelling going. That's what's causing these pockets. And then the bulk of the cool water, La Nina cool water, is out here from, let's say, 120 west and beyond. So that's what we've been saying. This La Nina is sort of westward displaced. It's made a little bit of inroads here to the east, but nothing significant. The trend for the past 7 days, blues are where water temperatures are cooling, reds are where it's warming. You can see here's a couple little pockets. We've noticed this La Nina pulsing right in here, and that's caused this area right in here to get a little bit cooler than normal, but still along Peru, Ecuador, nothing of any interest. You know, no sign that like La Nina's raging or anything. And then sort of this mixed bag pattern as it has been out to the date line. Then here's the, sort of the zoomed back view from a day ago. Again, before this was all, from 120 on, this was all warmer or just little pockets of cooler. So this channel here has gotten a little bit more carved out, but nothing super significant. The balance of the activity still seems here. Now let's compare this to maybe some other La Ninas. So here's the La Nina from 2010, 2011, after an El Nino of 2009, 2010. You can see a far more developed pattern here. Or let's compare apples to apples. Here's 2011. Here is this year's La Nina. Notice a significant difference. Look at the expanse. You get this kind of anvil thing going on, and we're talking the same time of the year here. And there's the core of your cool waters starting off the Galapagos. Then here is this year's event. Hardly even comparable. And then here's another one. This is after the big El Nino of 97, 98. You again see well-developed La Nina. Now, it's not the exact same perspective. You see the cool pool here. You see the anvil kind of shape thing, or the arrow pointing, if you will, to the West Pacific here. Okay, we'll go back to the one from 2011, and then here's where we are now. So this La Nina, very weak indeed. At least the signature at this point in time, we tried to the greatest extent possible to get all the same periods of time. The question is, will this La Nina roar to life? The thought is probably not. Let's take a look. Here's the forecast for the Nino 3.4 region. Let's show you where that is. Nino 3.4 runs from 120, 5 degrees north or south of the equator, to 170. So right here, you draw a box right there. That's the area that counts both for monitoring El Nino and La Nina. So here's the forecast for the next several months. Okay, currently, here was our El Nino back in January, the end of it into February, March. Temperatures in the Nino 3.4 region falling. Come June, we were neutral. In July, we moved into La Nina, but only a half a degree below normal. We've been sitting there. We're at the end of October now and still basically there. And then the forecast shows it getting a little bit deeper into January, down to maybe 0.9 below zero, not even 1 degree below zero, and then quickly rebounding and moving back into neutral come the spring. Here's another way to look at water temperatures in the Nino 1.2 region. This is the area between the Galapagos and Peru and Ecuador. You can see this sort of every couple of weeks, temperatures spike up and spike down. Maybe there is some effect of the MJO, though remember, we were looking at all the models, and the MJO just literally looked like it wasn't present. But you see these pulses, water temperature going up and down in a I don't know, 2 to 3 week or so pattern. Very similar to what one might suggest. Well, let's go pick it. Let's say October 2nd to October 15th. Yep, that's about every 2 weeks. And then you kind of go middle of September to the beginning of September, roughly. So current trend, temperatures moving up, suggesting the active phase of the MJO there. Let's go look at the Nino 3.4 region. And you get the same sort of periodicity here, a couple of weeks apart. Okay, but we're going down here. This might suggest, well, now remember, we're much further west. We're over almost towards the date line here. That might suggest, what, the inactive phase of the MJO right now. Temperatures down to below, actually the coolest they've been in this region now since this entire La Nina event at minus 1.1 degrees. Pretty much, on track with what the models are saying, maybe, somewhat. But what's going on in the East Pacific and the West Pacific are out of sync by maybe 2 weeks or so. So this still shows that sort of up and down sort of period. Let's go look at some other data. We're building something here. We'll show you. This is the real interesting stuff here. The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Okay, and you get a daily index out of that. Negative numbers suggest the active phase of the MJO. Negative numbers over a long period of time suggest El Nino. Anyway, so we kind of look back. Numbers were positive in early October, but as we get later in the month, notice we're down at minus 21, minus 35, minus 32, minus 20. Something's going on, and since it's been almost negative now since, October 19th. So what's that, about 10 days now? But that's not, this data is very noisy. You want to look at the 30-day average, really, if you're monitoring the MJO, Madden-Julian oscillation. So notice October 1st, we were up at 13.99, went up to 14.03, but then since then, October 7th, notice the numbers, the average has steadily dropped, and we were at neutral like 3 or 4 days ago, and now we're down into negative territory. This suggests that the active phase of the MJO or some other sort of tropical pattern is influencing what's going on. This is the piece of evidence that we're using to say maybe the active phase of the MJO is in effect. I mean, looking at the jet stream, looking at the storm pattern, this is not, it's not just magically happening. Something's driving this. And we're thinking it is the MJO, but it's not a normal MJO. It's a muted MJO driven, the La Nina's in effect. So there's not a lot of precipitation associated with it. And remember, the winds are still weak easterly in the Kelvin wave generation area, which is a real head scratcher. That we can't explain it. but nonetheless, the index is going negative, and the 90-day average, which is used to look for the presence of El Nino, well, was up to about, was at 8.42 there, October 7th. It's creeping its way down, but still, it's up at 4.58. Let's look at this data graphically, specifically the 30-day average. So here you go. This is the graphed over the past 2 years. January 2014, this was if you saw it prior to this, the 30-day average was in positive territory. We had been in like a long-running kind of La Niña pattern. All of a sudden, it went from plus 15 to almost minus 13 over the period of about a month and a half. Massive active phase of the MJO. Then the inactive phase tried to come in, but then it lost ground. And then you notice here, you can just pretty much run a line through this and see that we fell deep into El Nino. When you sit down here for a long period of time in negative territory, El Nino for sure, and you can see the pulses, inactive phase of the MJO, active, inactive, active, blah, 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 blah. But then you get into April, and then notice that we had this huge rise and really a continuous active phase of the MJO, or inactive phase of the MJO, I'm sorry. That's what would feed La Niña into sometime about the beginning of October. Now, here you go. All of a sudden, we're dropping from 15 to minus 3 or 4. That strongly suggests, irrespective of all the other data, that some sort of active phase of the MJO is in effect. We don't expect that it will stay this way. It's going to turn around and start heading back up north, positive territory. But for now, we think that's what's driving the jet stream. We think that's what's driving the storm track. We think that's what's bringing all the precipitation into California. It also gives us some hope that saying this La Niña must be not that strong. If you can get rain in California, you can get all this other, the storm track going on. Because typically, if you had a strong La Niña going, we wouldn't be seeing a whole lot of any of the symptoms that we're seeing right now that really suggest, if anything, we're kind of in a kind of a normal year, really, for this point in time. In fact, to have this much rain this early in the year is, if anything, a little bit unusual, at least relative to California. And yet, one more piece of information. The ESPI index, very much like the Southern Oscillation Index, only it measures total precipitation between the area north of Darwin, Australia, and Tahiti. When that area really here, this is the main area. If you were looking for El Nino, you'd want to see a lot of wetness here. The index would be positive. Right now, it's minus 1.84, suggesting the driest in this region than it has been all winter. You can clearly see that here in this pattern, this wedge, La Niña wedge sort of thing that we saw in the other pictures. This is average rainfall the last 30 days. And anomalies, notice, drier than normal right in here. Pretty typical. Again, that would suggest cooler water in this area. And that's because cooler water at the surface, that means less humidity and moisture going up into the atmosphere, less precipitation, so you get these negative anomalies. So clearly a signal of La Niña. But we're going to go back to this image just to sort of wrap things up a little bit. The MJO, we believe, is in some sort of active state, mainly due to the falling SOI, even though we have weak easterly anomalies in the Kelvin wave generation area. And mainly none of the models are really suggesting that the active phase of the MJO is in effect, though both the phase diagram charts that we saw suggest that the active phase of the MJO is in fact supposed to develop over the next 2 weeks. But we're going with that for now. The jet stream cannot be denied. The storm track cannot be denied. Rain in California cannot be denied. The question is, will it last? We'll see, but things are kind of interesting. So for now, a series of storms forecast for the Gulf of Alaska, working their way towards the U.S. West Coast. Swell looks likely for Hawaii, U.S. West Coast, down into Southern California and probably Mexico as well. Make the most of it while you can. It's La Niña. When you get storms and you get surf, better take advantage of it. Don't wait for the next one. Long-term outlook, for now, the MJO forecast to turn active, forecast to perhaps continue the pattern, though we did see weakness in the jet stream a week out. Whether that will be short-lived or not, who knows? Too early to tell. But surf is on the way. Get it while you can. All right, thanks for watching. We'll do this again next week. Same time, same channel.